Hello everyone, my name is Vishnupriya. Today we are going to discuss about Coursera, that is managing machine learning projects, and I have taken the topic about individual consumers to make environmental friendly decisions related to energy consumptions from their home heating and cooling system. So, problem statement is many individual consumers struggle to make environment friendly choices regarding to their home heating and cooling system due to a lack of accessible information and resources. This often made to reliance and conventional less sustainable options, contributing to increased energy consumption and environmental impacts. Addressing this issue requires user friendly guidance and incentives that empower consumers to adopt more eco conscious solutions, ultimately fostering a sustainable future. And today we are going to discuss about contents, opportunity evaluation, crisp DM your business understanding, solution validation plan, machine learning system design, and potential risk in production. So, coming to the first topic, opportunity evaluation. In that, we will study about feasible and data availability. Plenty of data exists on energy consumption patterns, weather, home insulation, and consumer behavior. This data can be useful in training models of machine learning for generating tailored solutions. And coming to second point, technology. Recommendation systems and behavioral prediction benefits highly from evaluated machine learning techniques. This problem domain has algorithm and framework already set up to use. And third point, expertise and resources. Through proficiency in data science and machine learning is essential. The information to execute the project is both documented and ambiguous. Besides, there is also availability in computing for training and deployment, which makes the possibility technically valuable. Coming to fourth point, market demand. Purpose is as more and more attention is being focused on sustainability across the globe, consumers are in need of support to minimize their carbon footprints. This tackles this important and immediate challenge at all. Target audience. This solution targets those who care about the environment, either from homeowners seeking green ways to heat or tenants aiming to make their home more eco friendly. This wide target demographic implies tremendous market opportunity. And coming to competitive landscape, existing solution or services in the market may target energy efficiency, but introducing a uniquely personalized recommendation system built off of machine learning might present an opportunity for some different things. Something potentially more impactful, which can potentially offer some competitive edge. And coming to individual empowerment, helping shoppers to get customized guidance allow them to act on how they can minimize their ecological footprints, and which can instill a feeling of accomplishment and responsibility in fighting against the climate change. And coming to the crisp DM business understanding, problem definition. Which problems are we trying to solve? Can you tell me? Yes, I can tell. Our goal is to encourage individual household consumer behavior change towards more sustainable way of consuming energy when it comes to home heating and cooling system. So why does this matters? Sustainability is absolutely essential given the increasing need for sustainable actions in the face of climate change challenges. By promoting eco-friendly energy alternatives, greenhouse gas emissions may be significantly lowered. Who are the main parties in this deal? The stakeholders include homeowners, renters, environmental advocacy groups, energy companies, and government entities. And what are the key business goals? This trend is aimed towards reducing overall energy use, minimizing carbon emissions, promoting eco friendly personal habits among customers. Defining success. How do we measure how much the business will be affected? Business impact can be estimated using lower energy usage leading to cost saving for homeowners and low green gas emissions. Matrices for outcomes and outputs and outcome matrices. The total reduction of electricity consumed and total monetary saving from the consumers and reduction in the amount of greenhouse gases released into our atmosphere, measured in millions of tons of CO2 equivalent, is reduced. Identifying influential factors, factor potentially of significance, consumer past energy consumption patterns, heating and cooling needs influenced by local weather conditions, insulation level and energy, conservation efficiency at homes, and consumer demographic. For example, say average household size and average household income. Consumer preference regarding what constitutes sustainability. Eco-friendly suggestions, affordability, and seasonal fluctuation in energy usage. Which of these can influence this situation? This element play an enormous role in effective of personalized recommendation. For example, weather data help us to when the heat and cooling system will operate, and consumer behavior dictates what we present as suggestions. Answering to this question, set a foundation for the understanding the defining what constitutes success in the project. This project provides the foundation upon which you can proceed through the stages of data preparation and modeling in CRISP DM methodology. And coming to the solution validation plan, the strategy is based on motivating individual householders to undertake sustainable habits related to the management of energy generation of heating and cooling equipment in the homes. To achieve this, we will build a recommendation engine based on machine learning. The system which analyzes historical energy consumption, trends, local weather data, and house insulation level, as well as consumer behavior to provide personalized, actionable suggestions for better consumption of energy. And execution of iterative experiment, data collection and pre-processing. Getting historic energy use from each customer, gather up local weather reports and information about your home insulation level, add some level of anonymity and aggregation for protecting privacy as well as maintain compliances. Normalize and clean the data to remove outliers and inconsistency. And feature engineering. Find relevant information such as time of day, sunrise and sunset, weather and level of insulation. Prepare an engineer feature for consumption in a machine learning algorithm. Explore relationship between variable and see how things are correlated. Model selection and training. Select sustainable machine learning model for recommendation engine, collaborative filtering, content-based filtering, hybrid solution, etc. Validating matrices. Define performance matrices like mean absolute error and root mean square error or even precision recall scores, etc. Assess the effectiveness of the initial model on the validation. Initial model evaluation. Use the specified validation matrices to evaluate the original model performance. Compare predicted and monitored energy consumption. Scaling and full deployment. Expand the implementation to address bigger number of users. Monitor system perform closely and address scalability issues as they emerge in the watch. Continuous monitoring and improvement. Real-time monitoring of performance and protecting you from the unexpected change in the data distribution. Make sure your model gets a continuous refresh of new data to keep pace with constantly changing customer behavior and external realities. And machine learning system design. Model complexity. Decision. I believe in somewhat complex version. Rationally. A somewhat complex model is an easy going model. Simple but performs well. With the goal of recommending personalized energy consumption, a sufficiently complex model will be able to represent how customers behave based on their individual household characteristics and the local environment. But it should not be too complex to avoid overfitting and keep interpretation easily and available. Batch or real-time processing decision. Opting for real-time processing irrationally. Real-time processing is vital to provide timely and relevant notification to the users. Users, especially in the energy domain, can be in a great need for real-time advice on how to optimize their usage, give the rapidly changing weather situations and unexpected happenings. These require platforms sophisticated enough to able to process the data promptly and offer recommendation close to real time. Online or offline learning decision. Promoting fusion of online and offline learning rationally. This allows continuous learning and adoption with respect to changing customer behavior and the environment in a market. Using offline learning enables model to train against historical data and perform periodic updates. However, for the later approach, where online learning is used to quickly flex their deliver methods based on the individual consumer preference and immediately changes in usage patterns. And potential risk related to promoting environment friendly home heating and cooling decision. And upfront cost. Transitioning to eco-friendly heating and cooling system often involves high initial investment, which may defer budget-conscious consumer from making the switch. Technological complexity. Consumer may face challenge in understanding and operating newer, more advanced system, potentially leading to inefficiencies or system malfunction. Limited availability and accessibility. Some regions may have limited access to environmental friendly technologies or insufficient infrastructure to support their implementation, creation disparities in accessibility. Disposal of outdated system. Proper disposal or repurposing of older, less efficient heating and cooling system presents an environmental change and improper disposal methods. Inconsistent regulator support. Change in government policies or incentives for eco-friendly system may lead to uncertainty for customers, affecting their willingness to invest in sustainable technologies. Addressing this potential risk required a coordinated effort from the policymakers, industry stakeholders, and environment advocates to provide financial incentives, education, and infrastructure support for customers looking to adopt more sustainable home heating and cooling options. Thank you.